Welcome to Center of Math's Problem of the Week. For this week's problem, we want to find all integers n, positive integers n, such that given integers x, y, z, satisfying x plus y plus z equals 0, we have x to the n plus y to the n plus z to the n is a perfect square. So first, to make this problem easier, we're going to take a specific set of x, y, z, and then look at whether or not these powers will give us a perfect square. So plugging in x equals y and z, we get equals minus 2x. X is any integer. We'll get this, our expression turns into 1 minus negative 2 to the n minus 1, that whole thing times x to the n. So given some n, this is going to be some integer. And so if n is odd, we can choose x to be some prime not dividing this factor here. And so this whole thing will have some prime to an odd power if n is greater than 1 and odd. And so in this case, this will not be a square. So n greater than 1 and odd, we can rule out. So now we're going to say n is some even number. So still working with n greater than 1, we're going to plug in x equals 1 here, assuming n is some even integer. So 2n minus 1 is odd, so we can pull out the minus, become plus. So 1 plus 2 to the n minus 1 equals b squared. It must be true for x equals 1, so this must give us a square. So 2 to the n minus 1 equals b minus 1, b plus 1. So these are both powers of 2. Say b minus 1 equals 2 to the k. So b plus 1 equals 2 plus 2 to the k. So b plus 1 equals 2 times 1 plus 2 to the k minus 1. Where k is some integer greater than or equal to 1. And so note this only works for k equal 1. Beyond that, 2 on the left. And so we must have k equals 1. In this case, b equals 3. And if b equals 3, this is 8. So n will equal 4 in this case. So we get n equals 4 is another potential solution if n is even. And all other solutions don't work. If n equals 1, that trivially works because we get x plus y plus z, but we know this is 0, so it equals 0, which is 0 squared. So 1 works trivially. So now we're just left with checking n equals 4. So if n equals 4 and x plus y plus z equals 0, so z equals minus x minus y. So minus x minus y to the fourth is the same as x plus y to the fourth. So we want to see whether or not x to the fourth plus y to the fourth plus x plus y to the fourth over 2 is always going to give us some square. And so this will, and we can see this by expanding x plus y to the fourth. So we get x to the fourth plus y to the fourth plus some other terms. And this thing on the right turns out it's equal to, as you can check, x squared plus x times y plus y squared, this whole thing squared. So, and this is clearly always going to be a square because it's just some integer squared. And so n equals 4 does work, and so our solutions are n equals 1 or n equals 4. Thanks for watching. Please check out centerofmath.org and follow us on Facebook and Twitter. Thank you.